Hi there and welcome to this new video on IGCSE Maths Tutors. Today we'll solve a question that involves a lot of things, so we'll be discussing bearings, the sine rule and the cosine rule. Let's read the question. As you can see, it shows a diagram and the wording says A, B and C are three villages. B is 6.4 kilometers due east of A. C is 3.8 kilometers from A on a bearing of 210 degrees. Find the bearing of B from C to the nearest degree. To get the bearing of B from C, first we have to draw the north at point C, and the bearing of B from C would be the angle that the north makes with line BC, which is this angle marked in black. The angle in question, as you can see, is divided into two angles, namely this angle marked in green and the other angle marked in orange. So we can say that the bearing of B from C is equal to the bearing of A from C, which is the angle that line CA makes with the north, plus angle ACB marked in orange. So first we'll attempt to get the bearing of A from C, and to do this we will look at point A, and there's a video that I've done that shows the rules pertaining to angles. The link of this video is shown now on the screen. I advise you to at least have a quick look at it. However, one of these rules is that the sum of angles around any point, including this point A, is equal to 360 degrees. And since this angle, which is the bearing of C from A, equals to 210 degrees, it follows that that angle in red is equal to 360 degrees minus 210 degrees, which is equal to 150 degrees. From this information, it can be quite simple to get the bearing of A from C, marked in green, as it is equal to 180 degrees minus the angle in red, since the angles in green and red are called interior angles, and thus this angle in green would be equal to 180 minus 150, which is equal to 30 degrees. Now we'll start looking at the value of angle ACB. We notice from the wording of the question that B is exactly east of A, and we know logically that the angle that the north makes with the east is equal to 90 degrees. Therefore, angle CAB, which is this angle, would be equal to 210 minus those 90 degrees. This is equal to 120 degrees. Now we have triangle ABC, where we know two sides, namely side AB and AC, and we know the angle in between. If you're familiar with the cosine rule, then you should know that we can easily get side BC using that rule, since the rule says that the square of the side opposite to the angle that we know, which is angle CAB, the square of the side opposite that angle is equal to the sum of the squares of the other two sides minus 2 multiplied by the product of those two sides multiplied by the angle in between. And therefore BC would be equal to the square root of 6.4 squared plus 3.8 squared minus 2 times 6.4 multiplied by 3.8 multiplied by cosine 120. If you do this calculation, you will find that BC is equal to 8.9286. To get angle ACB, we will now use the sine rule, which says that any side divided by sine the angle opposite to it is equal to any other side divided by sine of the angle opposite to that other side. So practically speaking, if we plug in the numbers, we have side BC, which is equal to 8.9286, which we just got here, divided by sine 120, which is opposite to this side, is equal to 6.4 divided by sine angle C, which is opposite to this 6.4. So if you cross multiply, you'll find that angle ACB is equal to inverse sine of 0.6 621, which is equal to 38.37 degrees. Now we got angle ACB in orange, and we had previously gotten the bearing of A from C marked in green, and therefore the bearing of B from C is equal to the summation of these two angles, which is equal to 30 plus 38.37. This gives us 68.37, but since the question asks us to get the angle to the nearest degree, it would just be equal to 68 degrees. But remember that all bearings have to be expressed as 3 digits, and therefore we add a 0 before the 68 and the bearing becomes 068 degrees. I hope you found this video helpful. If you have, please give it a thumbs up. If you have questions, please don't hesitate to leave them in the comments section below, and as usual, I'll see you again in the next video. Goodbye for now.